Yeah, so welcome everyone for Cloud Computing and Big Data, Lecture 8. The topic today is Infrastructure as a Service. In many ways, in one, it connects a lot of other material you had already in the cloud computing course before. So you will see here and there, I do some quicker walkthrough through the slides just because essentially we have been there already and basically just connecting different materials that we had in previous lectures. However, with this, we also introduce, of course, the kind of classification as a service. So it's quite important. But before we do this, let us just review what we had the last time in our practical lecture 7.1 that was actually held by Rocco Sedona, one of my PhD students. And I think you have seen that actually scaling up in a cloud and really doing large scale in terms of computing requires a lot of thinking. So it is rather a scientific topic than just an applied one. We have seen that adding essentially more and more nodes gives us, of course, lots of opportunities. That means we have not one or two GPUs in a small workstation or laptop anymore. We can go to 100 GPUs, and some of my PhD students just exploring thousands of GPUs interconnected for an AI problem. Of course, this requires AI problems, which are basically these deep learning problems and not anymore these small, shallow artificial neural networks or things like logistic regression we have seen, because then essentially you would have nothing to compute. But if you go to cutting edge models that also were presented by Rocco Sedona that you would use in image recognition like ResNet, residual networks, then you're very much in the millions and billions of parameters to train. And then, of course, each GPU you can get is your helper. And with this, we, from many days of computing, would break it down to a couple of hours to really do the computing for those models. Now, by doing so, however, you have different options of how to do the parallelism, how you interconnect those GPUs together in order to solve this problem. And you have seen that Rocco put an emphasis a little bit on this first one, which is data parallelism, that essentially all the different nodes have the same model inherently, and they exchange the average of the gradient just with a so-called MPI or reduce call. So they train independently, but every now and then there's a synchronization that then basically says and has inherent the gradients, which we know from the stochastic gradient descent is our learning in the first place. So this is one approach of doing it. Then we have basically seen the model parallelism. If the model is too large to fit basically in one GPU, and if you remember, this was a problem in the initial AlexNet I was presenting. When AlexNet came out, the GPUs were rather weak. So the whole AlexNet, which was a very nice, innovative deep learning network at that point in time, basically didn't fit it to the GPU. So you had to basically cut it in the middle to deploy it on two different GPUs. Luckily, the GPUs now today are much better. So basically we see lots of different movements there from Kepler, Volta, now to Ampere, A100s, cutting edge ones, that this is, let's say, very strong GPUs, that this is not necessarily always provided. On the other end of the scale, we see that, of course, deep learning models get more complicated. Now we're talking in research of inserting physics in those, right? That you basically have physics-informed deep learning, for instance. And with this, you have very complex models that, again, will be maybe going to the way of model parallelism. And then there was this kind of third category, which is more or less pipelining. It's not, let's say, a very fair comparison. The first two is really where, let's say, the main meat is going. But in pipelining, the idea is there, of course, to do different architecture for different purposes. And we see this also working here and there, for instance, in neural architecture search, something where you use automatically tools to get the right architecture right, where maybe here and there for some tasks, different deep learning architecture is actually relevant. And basically then Rocco hopefully also conveyed to you two messages. Firstly, not only the residual networks are more, let's say, computing intensive and have this interesting idea of having the skip connection that basically the normal ones we learned in our lecture 6 and lecture 7 didn't really have. We had always, let's say, one convolution was pooling and then basically having another convolution following, et cetera, et cetera. This is quite some innovation. But on the other hand, he also said it's actually not an easy endeavor to do basically this. You have lots of issues with batch sizes when you really scale up. You have to have the right libraries like Nickel for NVIDIA GPUs. So the question is, what happens when we go to, let's say, AMD GPUs? Do they have the same support in terms of software? So this is all not really evident. And finally, what Rocco also presented, which should give you always in cloud computing a very much good idea, the pricing. Right, one of its last one, or the large models on the last slide, essentially, GPT requires billions of parameters, and you have seen you need millions of euros if you go to the cloud and actually run it there. So these are all considerations really relevant if you go to large scale, big data sets, to large scale modeling. And today we clarify, let's say, more conceptual aspects again. That's why basically you see here the green parts in this lecture that we just finished, were essentially the material about your assignment 2. And now we will basically come back to some of these concepts we learned already very practically, and we'll conceptualize this in this kind of 3 lectures as follow, always having this as a service character. But this as a service character is very important in cloud computing to make it easy for users to adopt cloud computing. And also it basically reflects different levels of how you would use cloud computing. Very bare metal, or a little bit with virtualization, then platforms, and then also software. So let's come to this one by one, where we of course start with the lowest layer, so-called the provisioning of hardware and virtualization in the infrastructure as a service, and they build on each other in order to solve different user needs really in the cloud. And many of those you already have seen when we're using the AWS examples again and again. We come back to something called the Elastic Compute Cloud, as we already know, the EC2. And then we look a little bit on how we're launching these instances with so-called virtual servers, which reflects things we learned in lecture 4 about virtualization. I also show you a little bit again the models and payment options that you have there, and also again the idea of this virtualized CPUs. But this is all basically reflecting again what we partially already learned in lecture 4, and which we applied, of course, in some of the earlier lectures where I did some practical examples with machine learning. So the advanced part in lecture, in this part 2 of the lecture, is really thinking about then more the storage idea of things. So what about, not only computing, but what is the idea of S3, EBS, and EFS? We come to this. And also thinking about the elastic character, which we have in clouds. And then several different aspects which actually link to future lectures we will have, for instance, OpenStack, but also thinking about the deployment options, which are very relevant for us to understand when you should really move to the cloud, right? When you should it maybe do in-house better than in the cloud? And these considerations, we already touched again here and there, basically parts of it. But here we try to really have, let's say, different categories to really think about this when you are in the job, to come to your boss and says, these are our options. So what we should do. There are, of course, here and there some commercial examples that go beyond AWS. Of course, we use the marketplace of AWS with some examples, but also come then to Icelandic data center examples for Verne, but also, let's say, at Vanya and at North. So also I mentioned NetApp is also by further basically very relevant for Iceland application provider here. So let's go to IAAS provisioning, infrastructure as a service. And basically this cloud computing that you have already in everyday detail today, we have seen this slide before, could be very many different things. So basically you see that they are always on very different ends of the application scale, right? So we see here with Google Docs, really cutting edge applications, which are full software where you can write documents, where you have Excel in the cloud, things like that. On the other hand, we have then something like Amazon Web Services, where we know that some of these services like EC2 or the storage ones we will learn today are very rudimentary. So alone with this, you cannot do anything. You need to have another application doing so. And you can go on and go on. There are many different providers. Ubercloud is one that we also will touch base on, one which is very good with containers, things like Dockers or Singularity inside clouds. So all of this is very interesting because there's a huge market share of all these different platforms. And to understand a little bit their, let's say, inherent design and their unique selling propositions, we dive into these different categories, which we say as this as a service category inside the course, and which is also known in the community. And these levels are really, in a way, oriented towards users of cloud computing. You would say all of these users use those different layers, these 3 that we have, very differently. So you would have mostly administrators or basically people that are basically IT personnel working usually on this infrastructure as a service level. Of course, the platforms and the software, they take care also of this inherently. But if you, let's say, just are interested as a user for this, you're basically a very certain amount of, user community, or you basically are very much a representative for the, let's say, IT within a company. So here you have really a certain way of users that targeting just this and have to have the knowledge of these infrastructures. They have to know about virtualization, have to know about networking, security, SSH keys we discussed. Then on the next layer with the platform as a service, it's different. That's much more software developer that want to take different Lego bits and pieces and put them together to a real product, right? Things which are not yet a complete software, but which are the building blocks, so to speak, as a platform to create new software. For instance, credit card as one, credit card billing as one module, putting together with a virtualization and a visualization module, and then put together with, some databases to have your users basically tracked over time. So you put in different pieces, and we will talk about it, of course, in the next lecture much more. And then the software as a service would be really something where you swipe your credit card, you have nothing else to do than just using the software. Customer relationship management software, for instance, is very known. He has a very huge market share in this business. But of course, here you would also classify Google Docs, right? This is a software, you don't do anything. Of course, if you want to have more storage, you swipe your credit card, get in OneDrive or in Google more storage. But in the end, you don't have to deal with low-level hardware issues anymore. You don't also have to deal with, putting different pieces together. You just use the software as you go, so to speak. And these are all different users, basically, they try to serve. On the other end, I have to say it's a little bit, of course, also, let's say, not a very clear classification, right? Of course, it's a more conceptual topic. Once you go to the other ideas of the deployment models, where we said we have public, private, hybrid in one of the lectures that we had, if you remember, this was different than these different layers. And here you see more and more that people, of course, then also need to combine those on different levels and bring them together. One example might be Gradescope, which is in a sense a software as a service, but it needs, of course, the infrastructure as a service from S3 to store the exams, right? So this is, of course, something what they basically do by doing and providing their certain cloud deployment as an example, by just combining different pieces on different levels of these clouds, right? To make their public, private, or hybrid cloud working. So in a way, I tell you, this is a conceptual difference, but in the end, you would say, of course, clouds today really pull different pieces on different levels together in order to make a good product outside for the customers. So in a way, what I want to say with you is there are these kind of lines which would now say the users of all of these different lines and these different categories are, having different needs, but don't take this line too much by heart, right? When you go to an interview in a company and say you cannot combine infrastructure as a service directly with software as a service would be also wrong. Basically, of course, they build on each other. That's one thing. And the other is really that these kind of differences are sometimes a little bit, let's say, not a really straight dividing line. You could sometimes argue, for instance, in databases, you would say a database is quite, let's say, infrastructure for many people. A basic database like an SQL one or a NoSQL database. For others, this is already a platform, right? They would say, well, this is a NoSQL database, is rather platform. That's why it's sometimes not really a clear distinction. And what people then started with is to make their own names for it. And this is another example. They call it now database as a service. And what essentially saying is that there's IAAS, PAAS, and SAAS as the three main categories, but people have now come up with lots of different, their own created names for these elements. And we will go in the next lectures, more and more in these different categories. Here, SAAS will be one lecture completely where we talk about this. And then also for the platform as a service, here we want to cater more the needs of application developers. So think about, you want to do an app like, Angry Birds. What do you need in the cloud for it? You need certain different components to monitor your application, you launch the application, and to do some billing of customer. Billing is very important, right? This is return of investment. That's why you need this kind of part of the PaaS platform. And here we will do some examples in the Google Cloud in the next lecture, indeed. So, and the focus in this lecture is really thinking more on the lowest level. But as you know from previous lectures, we have actually touched on that again and again by just using compute nodes, by the virtualization lecture, which is essentially in this field to operate virtualized resources. You remember maybe the virtualized clusters idea, right? That the cluster is not anymore the physical cluster with all the GPUs and CPUs, but more, let's say, cut it in different pieces and provide it as virtual clusters to enhance the utilization. And here's also the playing field of people like Vern Global, right? Or Amazon Web Services. Many of those are actually on this playing field on the infrastructure as a service or the Advania data services. Of course, we have also seen that many of those provide, let's say, some additional software. For instance, Advania is also now doing with North something we call HPC Flow, which is then a more bigger solution. But of course, there basically are your contact point. If you have a startup, I would basically advise you to talk to Vern Global or Advania. There's also the Borealis data center, for instance, that you can use in order to talk. And maybe you get a different pricing model than the giants with Amazon and get a good deal with them in order to make a good company here in Iceland, at least at the beginning, before you don't have the big return of investment yet, right? For a startup, it's always a very hard period at the beginning. Looking on the Amazon Web Services, of course, there, the key idea is to have this rapid access, right? So it's just there, it's operational. Basically, you have always capacities. They have so many data centers that you don't be afraid of saying, tomorrow I need this and this amount of resources. With this, you have it basically instantly. And it's true, you can swipe your credit card and you get relatively quick resources, which is one key thing in the cloud. And we have also seen in previous lectures, they do this on a pay-as-you-go pricing. So this means essentially for what you use, you're just charged. You don't have, let's say, to build a big cluster, you buy it and have it in your own cellar. Here, you just basically are billed for what you use, and you can always kill the Spark cluster or you basically stop using it and then the payment is over. So it's also not really this big subscription models that you have maybe in some other elements where you basically have a yearly subscription to something, right? So it's very a flexibility model. And of course, for many business cases, this is just perfect, especially when we talk about peak times of, basically doing computing. I said for you, sometimes the tax reimbursement could be something for a company where they have to compute a lot of things, or the Christmas and Easter shopping where suddenly much more people going shopping online. So these are, let's say, just examples. And there, of course, having this elastic idea is just brilliant. And the interesting thing, however, is that it's getting more and more complicated. So if you look into Amazon the last 10 years, I'm teaching that. You see that, basically you have now 70 different cloud services to choose from. So basically for you as cloud users, getting more challenging to really understand what is the right service I need. They're almost all very interesting, but to really look through all of them takes more and more time. On the other hand, for Amazon, this makes, of course, sense to get into more and more market shares, right? Into more niche markets also. And there are different examples also for machine learning, which we will touch base on later with SageMaker, for instance, on the SAAS level, while they could also use the AMI, the machine images that we discussed, basically more or less on the infrastructure level. So these are two, let's say, completely different market segments that Amazon already fills. Hence, it's one of the key providers. And also the idea you have basically already known, and this is also, of course, our blocking factor why this year we can't do it really in the cloud computing course, because students always had to have some way or another the credit card. Or you go through this large, let's say, certification courses from AWS Academy and so on. But this is also something which is not nicely integratable in university research. Hopefully there's something new coming. But the idea of this, what you see on the slide, is of course now transferable to almost all cloud vendors, right? The first thing they will ask before you use, can you provide us with a credit card number? Even if they say it's basically very cheap, it's cost nothing for a year, or the first 6 months are free, usually they won't already have the credit card number, and by agreeing, automatically after 3 months or 6 months, you will be charged. And this is a model which has proven in practice very valuable, because people tend to forget where they subscribe to. And then suddenly in your credit bill, it will be billed months after months after months, and you maybe don't even use the service anymore. So here, incredibly careful when you go to this. Also, maybe start monitoring in a company. Where are all your subscription? If you're responsible for cloud computing in your company, you have to have an overview, basically across clouds. And this is a key challenge today. They're not interoperable. So you maybe buy a couple of services from Amazon, but you also buy some of MS Azure and some of the Google Cloud. And suddenly you lost track in the cost management tracking because all of these clouds don't really interact and you don't have a, let's say, one view of cost management. And this is, of course, very challenging, particularly for small, medium enterprises, basically for smaller ones. The large enterprises can deal with this. And here I brought you just some idea. It's a bit hard on this beamer again here in VR2, but hopefully online it's better viewable and visible here in the recording, that the service portfolio is just amazingly increasing every year, more or less, right? You see, of course, these fantastic topics like machine learning that you see here, very well represented in many, many different services, was just a couple of years ago, a little bit on analytics and a little bit, combined with compute maybe, but there wasn't this big machine learning because, as you know, and from the media these days, machine learning is an extremely hot topic these days. And that's why basically they provide you, of course, with a lot of services. And to look through all of them, to all understand them, motivates, of course, this AWS Academy business, right? So that you get certifications in many of these services on the one hand. And with this, in a way, it makes sense to do this AWS Academy business, especially for business that you are certified, machine learner in AWS. On the other hand, of course, they kind of make this vendor lock happening, right? So once you adopt these whole systems and services, you're kind of very used to the way how AWS is doing it and not how MS Azure or Google Cloud is doing it. So if you change your company and suddenly they are using Google Cloud instead of AWS, your certifications are actually not really relevant anymore. That's why you cannot also compare it with university education, right? And that's why we as university need to be open to really support all the different vendors and not offer just a certification in, let's say, Coursera or basically certification in AWS somewhere. When you look into the console, that's what we already have done in some of the lecture. Lecture 4 was basically about virtualization, and this is very well represented basically here in the AWS console. Of course, this is an infrastructure as a service level, which means this layer on top of the physical hardware. That's something what we want to achieve, right? This virtualization layer. And of course, for this, we need lots of different elements like storage and compute and so on. And then on a complete different lecture, basically area, we have seen machine learning in lecture 2, 6, and 7. You have then other services where you can build and create them. So, but the environment is very much optimized for these different types of users. So for the administrators on the one hand, which are more dealing on that level, and then for the real users of the cloud that don't want to deal with hardware on the complete another level. So they try again to get different users into the perspective, while infrastructure as a service is much more here. Of course, they support also many of the other ones in the other layers. The access then is something also we discussed already in one lecture. I just want to make the connection that mostly if you work on the infrastructure as a service level and you will be an expert in that area, you basically have to be an expert also in a way into security. You have heard probably that University of Reykjavik was hacked over the weekend. So you see there's really a need for this in the community. And also cybersecurity in every country is very important because there are people doing a lot of things. And you have seen Garmin watches a couple of years ago was hacked. So, and when you're responsible for this infrastructure and the computing and all the data of your customers, don't underestimate when you're on the infrastructure as a service level, that many of the aspects are also security related. These mean something like virtual private networks, security, how you can access the services. It means something how you can deal with so-called access in private public key pairs. The future will be maybe even quantum cryptography. So there are lots of, let's say, around aspects for the environment of a cloud. You see also here this kind of sandboxes that you see here, which are then created by some real router configuration. So if you're responsible for this level, you really have to have knowledge on these different topics, not only to know the difference between GPUs and CPUs and a little bit about fat tree networks. Here it's really experts on these different fields, which really require something on this level to really work well and be very secure. And basically, we have seen already how that works mostly. You keep the private keys always at your site, never put them somewhere, right? The public is something what you can upload to a storage cluster. The public you can upload to a compute cluster, wherever in the cloud. What you never upload anywhere is a private key. Could be an exam question, right? So private key always at your site, never be shared and never be uploaded. Then the tools and the functionality of these keys works reasonably well. It's basically giving you a very good security standard if you want, but even with SSH, there's lots of trouble in the security world. People can have breaches in, and once you're in, you have SSH forwarding and known keys and can hop from one system to another. So it's also an area where this is just, let's say, fundamental security. But if you dive into it, there's also lots of options to get basically, let's say, a system compromised. And many of the HPC systems actually during COVID-19 have been compromised in Europe. There were people hacking them and basically prevented us from doing COVID-19 research. So it's a very valid topic, these security aspects, which go hand in hand with infrastructure as a service ideas that we have seen in the course from, beyond storage and computing and so forth. Then to connect to something we had also basically seen, of course, the Amazon Elastic MapReduce and the MapReduce idea that we have seen, this whole framework, which we see more or less as a platform for doing something, right? We could do a word count as a software, very simple software, but this would be our software. We're reusing the Elastic MapReduce platform. And if you remember when I was showing and demonstrating it in one of the practical lectures, the first thing we did was SSH keys to be created. And then the base from Amazon EMR is infrastructure as a service still, right? So we were creating, of course, these, let's say, Elastic MapReduce servers and the workers on the traditional infrastructure as a service. Although it has Apache, Spark, Hive, all the open source tools as the platform for you there, it, of course, reuses everything which is in Amazon underneath. So S3 you have seen for the storage part. We come to this in the later part. And then also the EC2 again with all the different computing. And that's how the different levels essentially interact. And in many of these services, you directly already have seen that. And it's no basically secret on that. Of course, here we see also more and more specialized services coming into play. For this platform character, people use a lot of search. So let's have a search service as a platform character for the community. Data warehouse is a large user base, so you want to be prepared for this, and business analytics and so on, which go a little bit, let's say, beyond what we do in Hadoop and Spark in terms of statistics and analytics analysis. Then we said also streaming data gets more and more important. I cannot keep everything. And here and there, we touch again on all these different ones and examples in subsequent lectures. Just to show you a bit, of course, that these PAAS services live on top of infrastructure as a service and benefit, so to speak, from their existence. The EC dashboard was also demonstrated once. We had created this launch instance, which is now basically saying there's somewhere physical hardware. But when there's physical hardware, that's not enough for us. When we launch the instance, we want to have something. And we learned in virtualization, this could be an operating system, purely like a SUSE Linux or Red Hat Linux. Or we learned in subsequent lectures, this could be even something called this AMI image, which already has TensorFlow, PyTorch, Nickel, all the different deep learning frameworks in. So you see also this is where you would say it's essentially infrastructure as a service level. But if you see TensorFlow and PyTorch as a platform to do deep learning applications, then you see already that the difference between infrastructure as a service and platform as a service is a little bit vanishing, right? So it's hard to say if that is now really just the infrastructure. Some say maybe it's a platform for deep learning. But in one way, this doesn't mean anything from a, let's say, practical perspective. You would combine just the services you needed. This is more a conceptual exercise to understand a little bit the differences of these different cloud services. And here's an example that I showed you from these different SUSE Linuxes and Red Hat Linuxes, while here on the lower level, you see definitively the deep learning AMI images with all the different, let's say, deep learning platforms and so on that we use. There are different payment options. Usually you have a credit card involved. That's one thing. Of course, a key fundamental aspect, but then you can have very different ideas with maybe subscribing to several services. that you can use the different packages, or really per service, pay as you go, as they call it. Even if you have this, you also have to be careful. There are differences between pay as you go or pay for what you use. You have seen, for instance, the Apache Spark cluster. If that's up and running and not used, we still use it for us to have it up and running, right? So in this sense, it's basically pay as you go, and you can submit Spark jobs, but if you don't, that's your problem, right? You're still being charged for it. Your Apache service still works in the cloud actively. And there are some services, of course, which are done rather by nature, where you just pay for what you use. When you think about storage particularly, right? There's nothing running. You use a storage and you just pay for the storage that you really use and accumulate. And also there, of course, there are hidden interesting aspects. There's a Glacier, which is long-term storage, versus S3, which is an active storage. That's why also the pricing models are different. Important for you as a company is to define very certain specific quotas for your team members, so that they are not, let's say, go into the weekend or in a long weekend, Monday, Friday included, and then suddenly they come back and have spent, let's say, lots of euros for something they don't really control because it was automatically running in the cloud continuously. However, it's of course nice because you have ad hoc access. It's in a way a bit easy accessible, because they hunt you oft also with this free tier options. But if you look into this, you see here the free tier option. Again, once apologies here in the room, it's basically better in the recording. You see a very tiny CPU that is in the free tier, right? When you do a real application, you really want to have something lower here with proper memory and performance. But they hunt you and say everything doesn't cost anything for a month or two. But then when you look into this, it's often also, let's say, relatively weak, or let's say not optimal resources. And as you know, from the free tier, for instance, there was also no Elastic MapReduce or advanced services included, as an example. There's certain on-demand pricing. Also, Rocco was alluding to this, that of course, depending on how much these systems are used, they offer you interesting pricing models. So when there are regions where almost no CPUs is used, you get a relatively attractive hotspot price. So if you can compute there and can leverage this might be useful, but requires you to really monitor the pricing model and really be, actively doing so. And this is, of course, for some companies, just a lot of overhead. Of course, here you can actually win for some of the prizes. And this cost sensitivity we have basically seen again and again in the course, right? We talked about Spark needs really this very, very large CPUs with a lot of memory, right? Otherwise, it makes no sense. So when you go for too small for a Spark cluster, that doesn't mean anything. You have certain credits per hour, which is reasonably cheap. And if you want to do Spark, you rather should be here on this level, right? Where you basically have lots of memory available and basically can use the benefits of Spark properly. So this is all something what we have already, discussed. So in the end, this is just the way of how CPUs are differently used in different applications. And of course, they have all different pricing models. So just shortly summarizing a couple of elements for the infrastructure as a service before we break here. And then we continue with the second part later after the break.
What is IAAS? Infrastructure as a Service, also called IAAS, is a method of cloud computing that offers and manages instant computing infrastructure over the internet. It sits alongside SAAS and PAAS. In the IAAS model, a third party hosts servers, software, hardware, and other infrastructure components for users. It also handles system maintenance and system backups to decrease downtime and to quickly restore in case of an outage. Additionally, IAAS models are scalable and can be adjusted to meet demand as it arises. Workloads that change frequently and unexpectedly, as well as those that are temporary, are perfect for IAAS models. If you are wondering what your business could do with IAAS, here are some common situations. Number 1. Web applications. IAAS offers the system to support web applications, including servers and storage. Web applications can be deployed quickly and are easy to scale up or down based on demand. Number 2. Hosting websites. Traditional web hosting can be expensive. With IAAS running your website, the costs are decreased dramatically. Number 3. Testing. New applications requiring testing, development, and tweaking before it is fully brought to market. IAAS makes it economical to test and retest as often as needed to produce the right product or service. Number 4. Big data. Mining large amounts of data requires huge amounts of processing power. IAAS efficiently and economically provides this for big data analysis. There are a number of other situations in which IAAS can work perfectly, but here are some of the advantages. Number 1. Faster innovation. When you're ready to launch a perfectly laid product, IAAS can have you up and running within a short space of time. Number 2. Security. The right cloud service provider can offer the right level of security for your applications. Number 3. Reduced costs. IAAS allows business owners to move past the expense and time of setting up and managing a data center on site. This makes for an economical way to test and develop new ideas. Number 4. Disaster recovery. Outages can be devastating for business reliability and continuity. With IAAS in place, high availability and fast disaster recovery can be maintained. To find out if IAAS can work for your business, check out techfunnel.com for more information.
Okay, so that's all for the first part of the lecture. We continue the second part of the lecture after a couple of minutes break. Thank you.